The purpose of this video is to do two things. One, to prove that we've algebraically simplified the equation for the Kmat, the material toughness, from API 579 Annex 9F. And secondly, to prove that that equation matches the equation for toughness from the Pisarski paper. So first off, we have the API 579 equation. Let's start from the middle here and go back to prove that this is the same equation as what's in API 579. Okay, I'm going to flip back and forth. So in the middle, we have 70 exponent 0.019 times x minus t naught plus 30. So 30 plus 70 exponents. So let's go over here. And the base equation that we're looking at here is equation 9F.47. And that's 30 plus 70 exponent 0.019 t minus t naught. That's in degrees Celsius. Outside of that equation is the Weibull K naught equation. And it's going to be the Kmat inside there, and then minus 20, and then that's going to be multiplied by a natural log of 2 to the negative 0.25 power, and then add 20 to that. So we go down here. Got K naught, that's equation 9F.51. K naught equals 20 plus that K median for the 25 minus 20 natural log of 2 to the negative 0.25. Okay, so we get the same thing there. And then outside of that, we're going to do the Kmat equation. It's basically all of that Weibull, that K naught from the Weibull equation, minus 20, and then multiply that by the natural log of 1 over 1 minus p, the probability of failure, and the sample size, 25 over b, the sample width. That's a factor to move the equation right and left, and then 20 plus that. That's kind of our horizontal asymptote. So where does that equation come from? That comes from right here. Kmat 20 plus K naught, that's the Weibull mean, plus 20 natural log 1 over 1 minus f, 25 over L to the 0.25 power. That's equation 9F.53. Okay, so now that we've proven that this equation is the equation from API 579, it's the three equations put together. Then we simplify that, and it simplifies to this right here is basically the inner equation, the K median. Once we put it together with this, that becomes the Weibull mean. And then when we put the 20 plus on the outside and multiply it by this factor with the probability and the width, then that becomes the Kmat. Okay, so this is blue. The original one is blue. Our algebraically simplified version is blue. So what you'll see is that's going to make the blue line bold. So those match. Okay, so those match. And the next step is going to be comparing it to the Pisarski equation to make sure that that's the same thing. Let me do that in a second video here.